Okay, let's talk about an object like this one, a wagon, being pulled across a flat surface at an angle. So now the applied force is no longer just horizontal. It is actually being applied at an upward angle, okay, being pulled. Okay, think about when you are pulling a wagon. You are actually exerting a little bit in the upward direction as well as a little bit in the horizontal direction, okay? So the first thing that we're going to do is put all of our forces that are acting on the object on our free body diagram. Okay, so our object, this beautiful wagon, okay, always has gravity acting on it, and gravity is always going to act in the downward direction. So we're going to go FG. I like to label mine FG. If you want to label yours W for weight, whatever, that's cool. Okay, a wagon is being pulled across a flat surface, so it is on a surface. Surface means there is a normal force, Fn. It is perpendicular to the surface, so we go straight up because it's a flat surface. In this, it tells us that we have a coefficient of friction that we're going to find. So we know that there is some friction acting on the object. Okay? Friction always acts in the opposite direction of motion. Okay? The motion on a horizontal or flat surface is in the horizontal direction. Please do not just assume that it's across from the applied force. It's not always opposite of an applied force. Sometimes you don't even have an applied force, so that's not a good way to remember which direction friction is going. Okay? Always remember it's the opposite direction of motion. Okay? Now I just drew in the applied force, okay? It is being pulled at a 55-degree angle. The angle is made with the horizontal. Okay, this is where we break our applied force into its component vectors. We have the applied force in the x direction, FAX, and the applied force in the y direction. Remember, the A and the x and the y and the n and the g are all subscripts. These are to tell you the different types of forces. They're just labels, kind of like having a first name and a last name. They tell you which Jessica are you talking about, which Aaron, which Chris, etc. Okay? So, now that we have our free body diagram drawn, we are going to then write our net force equations. We have the x direction net force, and we have the y direction net force. Okay? We need to determine what type of motion is happening now. So it tells us in the problem that the wagon is moving with a constant velocity. Constant velocity means that the object is not accelerating. So we know both the x and y direction are going to be equal to 0. This is awesome. This is very helpful for us, okay? Next, we're going to say, okay, what forces do I have that exist on our object? Okay, well, in the x direction, that's everything horizontal. What is going left and right? I have F and FAX. Those are the only horizontal forces, completely horizontal. That's what it means, okay? Do not put anything that is up and down or at an angle in your x direction. Only things that are horizontal. So I'm going to write mine positive, then negative. You can write it negative F plus FAX. That's fine. It's the same thing. Whichever way you prefer, that's okay. In the y direction, what is completely vertical? Okay, please be careful here. Whenever we're talking about problems like this, the y direction is always the one that has the most mistakes. Okay, that's where everyone seems to forget something. Okay, Fn, it's up, positive. Fay, it's up, positive. Is there anything in the downward direction? Yes, Fg. Okay, so that's where you need to start. Next, Next, we're going to solve. Remember, get whatever is negative to the other side if you can. I need to find the coefficient of friction. So that means I'm going to get my friction by itself. We know FAX, right, this guy right here, is the adjacent to the angle. So that means it's going to be cosine. Okay, that's the substitution. We know friction's equation is the coefficient times the normal force. Okay, this is where we have to pause and say, oh, do I have a value for the normal force? No, not yet. We actually have to calculate the normal force using the y side of our net force equations. Okay, so that means we need to solve for Fn. We are going to take this portion of the equation and move it to the other side of the equal sign. We then get Fg minus Fay. Okay, this is positive on this side. When you move it to the other side, you do the opposite operation. Fg is negative. Move it to the other side, you get the opposite operation. So that's how you get positive Fg, negative Fay.